Welcome to my channel, viewers. And see, this is the recent fourth video. Okay, for differentiation. Okay, that is the first order derivative. Now here I posted the 9 questions. Okay, from some books. Okay, now see the question number 1, and here is undefined derivative. That is here. X is equal to, this is sec alpha, okay, minus cos alpha, and also given that y equal to sec alpha to the power n minus cos alpha to the power n. Okay, this is your question. Okay, we have to show x square plus 4 within the bracket into dy dx whole square equal to n square into within the bracket n square plus 4. Okay, now see, find derivative with respect to with alpha. Okay, this is sec alpha and tan alpha minus sin alpha. Okay, and take a common tan alpha. See here, this is tan alpha, then here is sec alpha by cos into cos. We take common tan alpha, so this is cos alpha. Now differentiate y with respect to alpha. That is n into sec to the power n minus alpha into sec alpha, and this is here tan alpha again, n into cos alpha to the power n minus 1, and differentiation of cos alpha, that is minus sin alpha. Okay, again take a common n into, here we take tan alpha, that is here. We have to take an this value is, if we added this, then this is here. Okay, tan alpha. Then we see this is sec alpha to the power n, and take a common alpha, and here we take a tan alpha. So divided by cos alpha into cos alpha. So take a tan alpha. So have there cos alpha to the power n minus 1 into cos alpha. Okay, I can write tan alpha, added this. So okay, now find dy dx, that is dy d alpha by dx d alpha, that is n tan alpha plus by, is this here, tan alpha. Okay, these are cancelled. Now this part are multiplied through this here and squaring both sides. See, there is a square, so sec alpha plus cos alpha whole square into dy dx whole square, and that is equal to n square, and sec alpha to the power n plus cos alpha to the power n, and this is whole square, and that can be written as like this is this is here minus, so we can write here sec alpha minus cos alpha whole square. So this is here 4 sec alpha cos alpha. See, a plus b whole square, that is a minus b whole square, plus 4ab. This is here dy dx whole square. So this is n square. Again right here sec to the power n alpha minus cos to the power n alpha whole square plus 4 sec to the power n alpha, and cos to the power n alpha. So their product is 1, this also here is 1. Okay, so now write here this is as a x. So x square plus 4. This is 1 here. So dy dx whole square is equal to n square, that is y square. So this is here 4 plus 4 whole square. So it's proved. Oh no, this is not a square here. This is the square of y. Okay, so it's proved. Next problem 2. So see, okay, number 1 is very interesting question. Okay, number 2. See, there is y is equal to x plus 1 by x plus 1 by x plus dot to infinity. So see, this x plus 1 by, if we omit the x, then this figure is same as y. So that's why y is equal to x plus, here replaced by y, and then multiply by y here, y square xy, then here plus 1, and now differentiate both sides. Both sides with respect to x. See, differentiation of y square is twice y and 2 to the power 2 minus 1, and the derivative of y is dy dx. And also this is u into v, x into dy dx plus y into derivative of x is 1, and the derivative of 1 is here 0. So we get here 2y dy dx equal to x into dy dx plus y. So taking common dy by dx, and the both where dx are occur, and that is there, and this y, and so we get here dy and dx, that is y by 2y minus x. Okay, this is your, okay, good. See, for question number 3, for 3 here, so y is equal to 1 plus a1 by x minus a1, a2x by x minus a1 into x minus a2, dot dot an x to the power n minus 1 by x minus a1, x minus a2, dot dot x minus n. So see, this is one of the interesting question. So how can we solve this? Now first we take a LCM of both first and second term. Then we get here x minus a1, and take a LCM, then x minus a1 are cancelled. So x by is this, okay, and a2x by x minus a1, and again x minus a2, then we get here an x to n minus 1 and dot dot, okay, see carefully, and again we take the LCM of them, of the first two of this second line, then we get here x minus a1, x minus a2. So multiply by x here, so we get here x square x a2 plus a2 x, now plus an x to the power n minus 1 by this into this into this, okay, dot dot dot, okay, there's a this is, okay, we will have it in here, but the n factor is there, so these two are cancelled. So I think this is here x square. Okay, for the second term, see, for the second term, the degree of x here is this. So here y is equal to, therefore we can write, if we take LCM on the nth term, so we get here y is equal to x to the power n by x minus a1, x minus a2, dot dot x minus an. Okay, see, this is a product on the denominator part. So, but here the answer is here y by x, and this all are term are addition. So now take a logarithm on the both side. Okay, so log y, and if we take logarithm of that, so n into log x, and then you get here there are the n factors, so log of x minus a2, so again log of x minus an, and now differentiate both sides, sorry, with respect to x, then you get here 1 by y dy dx, and that is here n by x, again 1 by x minus a1, again 1 by x minus a2, dot 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 1 by x minus an. As after n by x, here is a n factor, so 1 to n addition, n term addition here, a1 a2 dot dot to n, c. Okay, and here is n times of 1 by x, so each and every term of the next, each and every term with written by like that, 1 by x minus 1 by x minus a1, so same as 1 by x minus 1 by this is 2, so 1 by x minus 1 by this is an, and if we take a LCM, then here we get x into x minus a1. So see, this is here x minus a1 minus x. Okay, same as x into x minus a2. Then you get here x minus a2 minus x. Same as x into x minus an. So x minus an minus x. Okay, therefore these x are cancelled, and this is here minus. So now dy by dx here is 1 by y. So y are shifted to the right hand side like that, and take a common x on the each term. So we get here y by x. So see, match with this. So now this is here minus a1 by x minus a1. Again plus minus a2 by x minus a2. So see, minus an by x minus an. So again write y by x. So that is equal to a1 by a1 minus x. And this is plus a2 by a2 minus x. And this is an by an minus x. Okay, this is proved. Okay, see, this is the interesting question, question number 3. So see carefully. And now see the question number 4. For question number 4, students, more of the students just differentiate u by v method, but if we differentiate u by v method, then this expression is so see the technique here. We proceed another method, multiply by that. Okay, x into 2t square. Okay, now t minus it is what? Here is t square. Okay, this is t square, and then directly the expression will come out. Okay, now differentiate both sides with respect to the here t. This is here t. So differentiate both sides with respect to t. Okay, now 2 into x into 2t and t square into dx dt, and that is your derivative of t here is 1, differential derivative of t square is this, and differential of minus t square is minus 2t. Okay, now here is t into dx dt. See, t into dx dt. So divide by with t. First we multiply by that is here. So this is 1 by 2t. Okay. This is here 2t square. Okay, right. So now multiply, take account 2t. Okay, 2t. Then you get x plus 2t. This is at 2x. Okay, 2x. Then t. This is t. And dx dt. This is 1 plus 2t into e to the power minus t square, and divide by 2t, then we get the correct answer. This is 1 by 2t, and this is 2t by 2t, and e to the power minus t square. So this is here 1 by 2t, this is 1, and e to the power minus t square. This is your answer C. Okay? And now follow the question number 9. Y is equal to, this is your tan inverse, this is your 5x by 1 plus 6x square, okay, plus tan inverse 2 plus 5x by 2 minus 5x. See the inverse formula, 6x minus x is 5, again 1 plus 6x into x. Again divide by 2, then we get here divide by 2, this is 1 and 5x by 2 here. There was a mistake here with 5 and 2. Okay, divided by 5 on numerator and denominator part, then 2 by 5, then here x, and divided by 5, this is 2 by 5. Okay, 5 2 divided by 5 on numerator and denominator part, then we get here 1 minus 2 by 5 into x here. Okay, and then you get here, this is tan inverse 6x minus tan inverse x, and this is again tan inverse 2 by 5 plus tan inverse x. So these are cancelled, this is our y. So differentiate both sides, dy dx. Thus is tan inverse x derivative is 36x square, and dx of 6x is here 6, and differentiation of this 0. So 6 by 1 plus 36x square. Okay. Next problem 5. In my some video of binomial distribution, this is the given case and so that this, and it is the chapter of binomial distribution, and you can apply here derivative. Okay, you have to show the by derivative. And see question number 5. Given that 1 plus x to the power n, c0, c1x, c2x square plus dot 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 cn x to the power n. Okay, see, for the point number 1, if we differentiate, then c0 are absent. So, but in the first group, there is a c0. So, need to present of x here, but here is x absent. So, we can multiply by x on both sides. So, then after differentiate, then we get the formation of this. Okay, see here c0x, c1x square. The derivative of x square is 2c1. See, there is 2c1. You will multiply x by third term, that is we get here x cube, and derivative of x cube is 3x square. Then after we put the value of x is 1, so then we get the answer. So multiplying by x on both sides. Then x into 1 plus x to the power n, and c0x, c1x square, c2x cube. This is the cn x to the power n plus 1. Differentiate both sides with respect to x. Okay, so that is ddx of x into 1 plus x to the power n. So derivative of x is 1, c1. This is a 2x, 3x square, c2. There is n plus 1 into cn x to the power n. And derivative this is as a u into v. So x into dx of that, so n into 1 plus x whole to the power n minus 1, and 1 plus x whole to the power n here. c0 2c1 into x, 3c2 into x square, then n plus 1 into cn and x to the power n. Okay, now putting x equal to 1, okay, on both sides. So if you put here 1 in place of x, so n into, this is 2 to the power n, this is 2 to the power n, this is c0, 2c1, 3c2. This is an n plus 1 and cn. So on the right hand side you can transfer to the left hand side in c2. This is an n plus 1 and cn, and that is equal to, take a common here, like n into 2 to the power n minus 1, 2 to the power n minus 1 into 2, and okay, this is here 2. Good. See, it's true here. And for the second, okay, this is the 5 part 1, this is 5 part 1. And now for the second, differentiate this for second, differentiate this, so ddx of 1 plus x whole to the power n, and differentiate, this is 0 here, and this is 1 c1 into x, we differentiate this here 2 into x c2, and then after we get here n into x to the power n minus 1 into cn. Now see here, plus minus like this in parallel x, this is, so putting, differentiate, there is option of this, okay, differentiate this, right here, n into 1 plus x to the power n minus 1. Okay, now putting x equal to minus 1, then this is here c1, so put here minus, so you get, okay, and the next term, this is there is a 6 x square, so you get here plus 3c3, so plus n, and this is here minus 1 whole to the power n minus 1, and this is cn. Okay, this is cn, c, and this is equal to n into 1 plus 1 minus 1 whole to the power n minus 1, so it's a 0. So 5 number question is complete. Now for question number 6, the very important question. For that question, see, there was a answer is here subject to the x here, okay. But for this question, there is a two type of answer. And dy by dx is subject to x, and dy by dx is subject to y. Okay, now see, first of all, we want to first show the subject to y. Maybe we have to prove this question. See, this is y and this is also y. So x is equal to sine y by sine of a plus y, and this is the subject of y. So differentiate this with respect to y. Differentiate both sides with respect to y. Then dx dy, and that is u by v. Okay, so sine of a plus y, okay, and ddx of sine y with respect to y, this is cos y. Okay, again sine y, differentiate this with respect to y, you can write here cos of, so a plus y with respect to y, okay, and ddxy is 1, okay. Now this is here sine a cos b cos a sine b, so you can write here a plus y minus y, and this is here sine square a plus y, so this is here dx dy. So now you can write here dy dx is equal to sine square a plus y and by sine a. And this is another solution for this question. And now here we have we find here the respect to the subject to the y. Now next question, for this question, you see there is a subject to x. So see, for this question, okay, there is a plus y. You can write here in place of y, a plus y minus a, and this is x into sine of a plus y. And this is sine a cos b cos a sine b, you can write here, okay, and this is cos a minus sine a into cos of a plus y, and x into sine of a plus y. Again see, divided by cos y on both sides, sorry, sine a plus y, then here is 1 and we get here cos a, and this is here sine a, cos by sine, this is cot of a plus y, and this is here x, and you get find the cot of a plus y. So this is sine a and cot of a plus y, and is equal to, okay, and this is cos a minus x. So now find this is cot of a plus y is equal to cos a minus x by sine a. Okay, cot a. Now find here a plus y subject to the x, that is cot inverse of cos a minus x by sine a. Now differentiate, okay, both sides with respect to x. So g0 as 0, and this is dy dx. And derivative of cos x is equal to minus 1 by 1 plus x square. X square meaning is this, okay? Cos a minus x by sin a whole square. And again differentiate of this. So this is here 0 minus 1 by sin a. And simplify minus minus plus and take a LCM here is that is by sin square a. And this is here sin square a, and this is a squaring split the formula of whole square, that is cos square a plus x square minus 2 cos a into x. And here is this is here into 1 by sin a. Okay, so that is equal to, this is here dy dx. Okay, so this is here sin square a into 1 by sin a. Now sin square plus cos square is 1 plus x square minus 2x and cos a. So this is the answer, sin a by 1 minus 2x cos a plus x square. This is your answer, okay? Very interesting question. Students, carefully, okay? So now we have to follow the last two questions, and this is 7 or 8. This is also a very interesting question. Students, see carefully. Next, we have to introduce more derivative. I think I want to introduce a more 5-6 derivative video classes. Okay, now see for 7 number. Okay, here is y is equal to, and that is tan inverse, and this is tan x plus sec x minus 1. This is here tan x sec x plus 1. In place of, see the technique here, this is here tan x and this is here sec x. In place of 1 can represent here sec square x minus tan square x. Okay, now we have tan x minus sec x plus 1. And now write here tan inverse and take account this is sec x plus tan x. Then we have left the factor as 1 minus sec x plus tan x. Again on the denominator see tan x minus sec x plus 1 here also. So tan x minus sec x, tan x minus x plus 1, both are cancelled. So this is here tan inverse sec, this is 1 by cos, 1 by cos, okay, this is cos, take LCM 1 plus and sin x. Okay, see again, this is tan inverse, we can write like 1 in place of 1, we can write here sin square x by 2 plus cos square x by 2. Then after sin x, this is 2 sin x by 2 and cos x by 2. Okay, now cos square x by 2 minus sin square x by 2. So that is equal to tan inverse, this is cos x by 2 plus sin x by 2 whole square. This is cos x by 2 minus sin x by 2 cos x by 2 cancel. So this is tan inverse divided by cos on both sides, so you get here 1 plus tan x by 2 by 1 minus tan x by 2. Not both sides, denominator and denominator part. Okay, for this we have to divide it by cos x by 2 and also this by cos x by 2. So this is 1 and this is cos by sin is tan, and this is 1, this is cos sin by cos is tan. Okay, so then in replace of 1 and this is here is 1, we represent as a, see, this is tan pi by 4 plus tan x by 2 and again 1 minus tan pi by 4 into tan x by 2. So you can write here tan inverse tan of pi by 4 plus x by 2. So tan inverse tan, and so we have left here, that is pi by 4 plus x by 2. Okay, differentiate both sides with respect to x. Then we get here dy by dx and ddx of pi by 4, it is 0 here, and half into this is ddx of x. So you can write here 0 plus half is equal to half. Okay, so half is the answer. Okay, next question is 8 here. This is also an interesting question. See the solution here. This is a given that y tan inverse. So this is a 8 y tan inverse. So same pattern. This is 1 plus this is t square, and this is a 1 minus t square. 1 plus t square plus, and this is 1 minus t square. So let us assume t square as a cos 2 alpha. So then tan inverse and root over 1 plus cos 2 alpha, 1 minus cos 12. Okay, this is here 1 plus cos 12 alpha minus 1 minus cos 12. This is here tan inverse. So see 2 cos square alpha, 2 sin square alpha, 2 cos square alpha, 2 sin square alpha. Tan inverse, okay, and this is root 2 cos alpha, root 2 sin alpha by root 2 cos alpha, root 2 sin alpha. Okay, take a common, okay, then cos alpha plus sin alpha, then okay, divided by cos alpha on numerator and denominator in the bracket. So we get here 1 plus tan alpha, this is 1 minus tan alpha. So that is equal to tan inverse tan pi by 4 plus tan alpha, then 1 minus tan pi by 4 into tan alpha. So we write here tan inverse tan of pi by 4 plus alpha. So pi by 4 plus alpha, pi by 4 plus alpha. So see here, alpha means cos 2 alpha means t square. So 2 alpha means cos inverse t square. So alpha is equal to half cos inverse t square. Okay, here half cos inverse t square. Then this is the y. So differentiate both sides with respect to t. This is a function of t. So this is wrongly written. This is respect to t. Okay. So this is here respect to t. This is 0 plus half and d dt of this is a cos inverse t square. Okay. So half. This is minus root over 1 minus t to the power 4, and derivative of t square is 2t. So see, this is here minus t by root over of 1 minus t to the power 4. This is your answer. Okay, T2. Okay. See carefully, and this is today's video is very important classes for 11, 12 and others completing the exam. Okay, in my next video we have to introduce the more solution of derivative and different type of technical solution of derivative for joint additive entrance. And there is some point just I have to introduce here today. Okay, see carefully. Okay, do the problem.